Good evening, my name is Everardo Nuncio, and in this video I'll show you how to perform a 2 to the k full factorial experiment. In this case, I'll talk about an experiment that involves polymers and the production of these ones. Right now I'll show you a little video about this phenomenon. In the following images I'll show you what the problem talks about in this case. Once you have organized your data, we shall proceed to the first step. First, we'll have to check for the dispersion and location effects. But first, we'll talk about the location effects. So, for starters, we'll have to proceed with the Yates algorithm, which will be described in the following sequence of images. Now, the location effects will be calculated with the following formula. After the Daniels test has been done, we'll have to conduct an analysis of variance. For this, we'll have to use the previously obtained significant effects and then assign them in a table for the ANOVA, which means analysis of variance. The problem tells us that we have some augmented points in the center of our model. Therefore, we'll have to check for curvature. For this, we'll have to use some formulas that are explained in the following sequence of images and video, where I'll show you how we must calculate some terms. After this has been done, we'll have to check for our sum of squares for each of the significant effects of our full factorial experiment. After we have finished calculating the sum of squares of our significant factors, we'll have to check for the sum of squares of the pure quadratic term, which is calculated using this formula. After the significant effects have been calculated, now we can use this to write our model or our experiment into an equation. In this case, we'll use the formula that's given in the image presented, as is y equals the average of the model plus a summatory of every significant effect times 0.5 times the corresponding x variable. After we have our equation that represents our model, we'll have to use this one to obtain the residuals of our same model. For these residuals, we'll have to use the coded values of each variable, in this case +1 and -1, and then we'll calculate the expected value, and after we have calculated all of the expected values, we'll use this to obtain our residuals. For the residuals, we'll have to use the formula that says that every observed value, as in our experiment, minus the expected value will give us a residual. After we've calculated the residuals, we'll have to proceed with a constant variance test. In this test, we'll use the table of signs, and for each +1 and -1, we'll assign them a certain residual, and then we'll plot them in a XY axis. Right after we've finished this test, we'll have to proceed with the same previously done tests again, but this time with the other totals or the other column of yield, the one that involves the second response variable.